Well, welcome back. In this video, we're going to look at solving quadratic equations. And what we're looking for, this is sometimes called finding zeros or finding the roots. What we're looking for when we're saying solve that quadratic equation, we're looking for the 2 points where the parabola crosses the x-axis. Where is that going to happen? And we can do that if we have our equation in standard form, which is ax squared plus bx plus c equal to 0. And then we're going to use something called the zero product rule. And what that states is if two quantities are multiplied together and they equal 0, then either A has to equal 0 or B has to equal 0 to get the zero product. So looking at the example of the quantity x plus 3 times x minus 7 equal to 0, then that zero product rule tells me that x plus 3 has to equal 0 or x minus 7 has to equal 0 in order to achieve that zero product. So when we go about solving quadratic equations, the first thing we need to do is write this in standard form. Equal to 0. So ax squared plus bx plus c equals 0. Everything needs to be on one side of the equation. After that, we're back to factoring. We're going to factor that quadratic expression. Then we're going to use the zero product rule. Set each of those binomials equal to 0 and then solve each of them for x. Let's take a look at our first example. We have solve 2x squared minus 11x equals negative 15. The first step says to write it in standard form, so I need ax squared plus bx plus c equals 0. So I need it equal to 0. So to eliminate the 15 from the right side of the equation, I'm going to add 15 to both sides of the equation. So I'm left with 2x squared minus 11x plus 15 equals 0. Step 1. Step 2 says to factor that quadratic expression. My factoring rules haven't changed. First off, greatest common factor. Do we have a greatest common factor between 2x squared, negative 11x, and a positive 15? No. Is it special, or does it fit a squared minus b squared? Nope, I've got 3 terms, so I go to my next. Oop, I can't count. Should be step 3. Does a equal 1? No. So finally, that means I need to factor by grouping or do that AC method. A times C equals 2 times 15, which equals 30. So I need factors of 30 that add to a negative 11. I'm going to make a chart just to review for us. Factors of 30 that have a sum of negative 11. Because I have a negative sum, I will need to use negatives on my factors. Negative 1 times negative 30 give me positive 30, but they give me negative 31. Negative 2 times negative 15, they give me negative 17 when I add them. Negative 3 times negative 10, negative 13, well, I'm getting closer. 4 is not a factor, so negative 5 times negative 6, when I add them, give me negative 11. That's my set. So that was a quick review on how to find two numbers that have a certain product and a different sum. So now we take the two factors we found and we split that middle term. So I have 2x squared minus 5x minus 6x plus 15 equal to 0. Factor by grouping, remember we divide and conquer. I look at the first two, find the common factor. In this case it's x, so I'm left with 2x minus 5. And my second or last two terms are going to have a common factor of 3, but remember my binomials have to match exactly, so I'm going to factor out negative 3, and that leaves me with 2x minus 5 equals 0. So I'm left with x minus 3 is one of my binomial factors, and the second one is the common binomial factor. When I'm at this point, I'm going to go ahead and erase just a little bit here to give me some more room. There we go. Now I'm going to use that zero product rule. In order for the quantity x minus 3 times the quantity 2x minus 5 to produce a product of 0, x minus 3 needs to equal 0, or 2x minus 5 needs to equal 0. So I just take each binomial, set it equal to 0, and solve. In my first one, I'll add 3 to both sides, so x equals 3. In my second binomial, I'll add 5 to both sides, so 2x equals a positive 5. Divide both sides by 2. 2.5, or you could have left it at 5 halves, whatever you want to. So what this is telling me is that my graph of my parabola, which opens up because my coefficient of my quadratic term is positive, is that the graph crosses the x-axis at 3 and at